Hi everyone. Today we're going to talk about cofunctions and the cofunction identities. And I'm going to start with talking about some trig function pairs. And let's start with the ones we know, because I don't want you to get these two mixed up. We already learned that the trig functions come in reciprocal pairs. So for example, sine and cosecant. Sine and cosecant are reciprocals. Whatever one of them is, the other you get by just flipping. Same with cosine and secant. Same with tangent and cotangent. So each of those are reciprocal pairs. Now what we're going to do is we're going to talk about a different type of pair today. So you may have noticed as you were learning the trig functions that the names come in pairs, and they're actually different pairs than except for one's the same, but two of them are different from the ones we just learned. Now what I mean by the names is that for each of three trig functions, there's a trig function, and then the same thing with the prefix co or co. So you have sine and cosine. You have secant and cosecant. And you have tangent and cotangent. Now these are our new trig function pairs we want to talk about today. They're not reciprocal, so make sure you don't get them confused. In fact, the easy one is tangent and cotangent. Those always go together. But sine and cosine, secant and cosecant are not reciprocals. What they're called is cofunctions, and that's what I want to talk to you guys about today. So let's talk about coangles. If you have a right triangle, in fact, let me draw one for our lesson today. You have this right triangle here. The two acute angles, meaning not the right angle, the other two, they're called coangles. And they always add up to 90. So if I put a number in here, like let's say for example, I told you that this angle was 20 degrees, just to make up a number, then you would say, okay, well that's easy, this one's 70. Just subtract from 90. Now what we want to do instead of that is let's make it a little bit more generic. So let's say this angle right here is theta. Theta, we'll do degrees again, theta degrees. If I wanted to figure out what the other angle is, I would subtract from 90. That would make the other angle 90 minus theta. Those are what we call coangles. And what happens is if you switch from one to the other in a problem, if you're thinking in terms of SOHCAHTOA, what it does is it flips opposite and adjacent. So if I'm solving this triangle using SOHCAHTOA, the one thing that never changes, this is the hypotenuse. That's never going to change. Now, if I'm using the angle theta in my question, that makes this the opposite leg and this the adjacent leg because it's opposite from theta or adjacent from theta. Now, all of a sudden, if I start talking about 90 minus theta in my question, if I talk about the other angle, it switches these two. Opposite becomes the bottom, and adjacent becomes the right-hand side of that triangle. So that's how coangles work. If you switch back and forth from one coangle to another in a problem, hypotenuse never changes, but it switches opposite and adjacent. Now, when it switches opposite and adjacent, what happens is each pair of cofunctions switches. So like sine becomes cosine, secant becomes cosecant, and tangent becomes cotangent. So a good way to think of it is like this. Whatever sine of this angle is cosine of this angle. And vice versa. Whatever sine of 90 minus theta is cosine of theta. And it works for any of the pairs. Whatever secant of one angle is cosecant of the other, and vice versa. And whatever tangent of one angle is cotangent of the other. So those give you what we call the cofunction identities. And I'm going to go ahead and click through them. This is how they would look in a textbook. Number one, and this is pretty much exactly what I just said in words, but we're putting it into equations. Sine of one of the angles, 90 minus theta, is cosine of the other one, theta. Or backwards. cosine of the 90 minus theta is sine of theta. Then it works with secant and cosecant. Secant of one is cosecant of the other. Cosecant of one is secant of the other. And then finally with tangent and cotangent. So basically what we're saying is if you flip back and forth from one angle to another in this right triangle, it switches each pair of cofunctions. And remember, I've said this a couple times already, what's really important is that you don't get this mixed up with reciprocals. We have two different ways of pairing up trig functions. We have reciprocal identities and we have cofunction identities, and they're different. If you get them mixed up, that causes problems. Now, I've been using degrees for my example because we were talking about a right triangle. It, of course, works for radians too. So if any of those 90 minus thetas were pi over 2 minus thetas, same thing, same identities. So what I like to do is take these like math book type rules, show them to you, but then put it into words. So here's how I think of the cofunction identities. If you're doing any type of problem at all with any of the 6 trig functions, sine, cosine, tangent, secant, cosecant, cotangent, if you see that the angle that you're taking the trig function of is one of those two things, either 90 minus theta if you're doing degrees, or pi over 2 minus theta if you're doing radians, you can change those angles into just theta, which is much better. It's always better to have a more simple angle by switching to a cofunction. And what that means is if there's no co there, put the co there. If there's already a co there, take it off. So for example, let's say I'm doing a question, and somewhere in this question it says secant of 90 minus theta degrees. And you look at it and you go, oh, I noticed that. That's my I mean, that's the thing about the cofunction identities. They have a very specific use, and you have to recognize that it's time to use them. So when you see that 90 minus theta, that's a red flag for you. And you go, I want to use my cofunction identities. So you say to yourself, I can change this 90 minus theta into just a theta by changing this into its cofunction. Now I look at the function, it's secant. It does not have the co in front of it, so I'm going to put it there. I'm going to change secant into cosecant. Now cosecant would be CSC. So if the question was like solve for theta and it said secant of 90 minus theta, that looks hard. If it says cosecant theta, that's much easier. So you've simplified the angle, which usually simplifies the question. Another one might be maybe you had cotangent of pi over 2 minus theta. And you look at it and you go, well, that's in radians, but I still recognize that's a cofunction. Pi over 2 minus theta works. So you say I can change the pi over 2 minus theta into a theta by changing the function into its cofunction. Now this one was a cotangent. The co's already there, so just get rid of it. Cotangent becomes tangent, and you have tangent theta. So again, if this was like a solve for theta question, cotangent of pi over 2 minus theta is difficult. Tangent theta is very simple. So you've made it easier that way. Now remember, it has to be exactly this. It has to be exactly 90 minus theta or exactly pi over 2 minus theta. If it's pi minus theta, that's not a cofunction. If it's theta minus pi over 2, if they're flipped and they're backwards, not a cofunction. It has to be exactly that, 90 minus theta or pi over 2 minus theta to use these. So let's go ahead and talk about our next question, our next problem type. We've done a question like this using the unit circle, where I ask you to find any or all trig functions. I might just say find sine theta, or I might say find all 6 trig functions for theta. We did it with the unit circle, and now we're going to say, what if it's not a unit circle value? What if it's not one of my main numbers or main angles on the unit circle? So here's the steps. If you can't use the unit circle, your second best choice in trig is SOHCAHTOA. So we're going to draw a right triangle and label one angle theta. We're going to use the given trig function and SOHCAHTOA to label 2 of the sides of a triangle. Remember, every trig function is a ratio and represents 2 sides. If it's sine, it's opposite over hypotenuse. If it's cosine, it's adjacent over hypotenuse. If it's tangent, it's opposite over adjacent. But fill in those two sides on the triangle. Use Pythagorean theorem to find the last one. And then answer the question. So let's try that out once. This will be it for today. This is our example for today. So we are going to find cotangent of pi over 2 minus theta if sine theta equals 4/5. So the first thing I notice, and remember we talked about this 2 slides ago, I see that pi over 2 minus theta, and it has to be a red flag. I have to notice and immediately say, wait a minute, that's a cofunction. I can make this question easier. So I'm going to do that. I'm going to take this pi over 2 minus theta and change it to a theta by taking this cotangent and changing it to its cofunction. No, it's a cotangent. It's already got the co on it. Just get rid of it. It becomes a regular tangent. So now realize this question, it's not asking you to find cotangent of pi. I mean, it is, but an easier way to think of this question, instead of trying to find cotangent of pi over 2 minus theta, just find tangent of theta. So now the question says, if sine theta equals 4/5, we're still going to use that part. What is tangent theta? So let's do that part. Now, what I'm going to do next is I'm going to draw a right triangle. You can draw it any way you want, as long as it is a right triangle. And then we're going to label one angle theta. Now, the way I drew my triangle, remember every triangle is different, but the way I drew mine, this is the hypotenuse, this is opposite, and this is adjacent. Because I put theta in the bottom corner, so that makes adjacent over there on the right. I'm sorry, opposite over there on the right. Okay, now the trig function that was given is sine theta. From SOHCAHTOA, sine is opposite over hypotenuse. So that gives us two of our sides. Opposite is 4, hypotenuse is 5. Now, what I'm trying to find in this question, remember, look over there in the blue. What I'm trying to find is tangent theta. Now, from SOHCAHTOA, tangent is opposite over adjacent. So I need to figure out what this last side is so I can do opposite over adjacent. And to find that last side, we're going to use Pythagorean theorem. We're going to use a squared plus b squared equals c squared. C has to be the hypotenuse, so I'm going to put the 5 squared here. The two legs can go in either order. One of them is what we're trying to find, so I'll put an x there, and the other one is the 4. So I get x squared plus, that would be 16, equals 25. We'll subtract 16 from each side. We get x squared equals 9. Take a square root, and x equals, now technically, I don't want you guys to forget this step later. Technically what we get when you take a square root is plus or minus 3, because you always get a plus or minus for a square root. But then you say, well, it's a triangle. There's not going to be a negative side on a triangle, so I'm just going to say x equals 3. So my missing side is 3. And I also want to mention, probably a lot of you knew that without doing Pythagorean theorem. 3, 4, 5 is a very common Pythagorean triple. So if you ever notice that pattern, I don't need you to do the work. Like if you had seen that original question, said a 5 and a 4, okay, I know it's a 3, 4, 5 triangle, you can just put the 3 in there, that's fine. But I went through the work just to show you how it's done. And now we're ready to actually answer the question. So remember, what I'm trying to find is tangent theta. We figured that out at the very beginning. Tangent theta from SOHCAHTOA is O, opposite, over A, adjacent, 4/3. And that's the answer to the question. So answering the question part was easy. The two tricks to this was, number one, using cofunction identities to realize what you're even being asked. If you're trying to find out what cotangent of pi over 2 minus theta is from this picture, it's very difficult, very tricky. But if you realize that I was really just asking you what is tangent of theta, it's very easy. And then the other part was understanding this is going to be an important problem for us. Me giving you one single trig function, I gave you sine this time, I could have given you any of them, but you got to be able to take that trig function, use it to build a triangle, finish the triangle, and then you can use the triangle to answer any question.